In this video, we'll look at the Heathkit GR-54 Deluxe Shortwave Listening Receiver. We'll look at the history of the radio, its features, and take a look at it inside and out. I'll discuss the restoration of this particular unit and demonstrate it being operated. Heathkit was well known as the premier manufacturer of electronics in kit form from the 1950s into the early 1990s. Their product line included shortwave and amateur radio equipment. At any given time, Heathkit typically offered several shortwave receivers in different price ranges. The GR-54 was a mid to upper range general coverage receiver covering long wave, the AM broadcast band, and shortwave up to 30 MHz. It was offered from 1965 to 1971, initially at a price of US $84.95. Typically, it was one of a range of shortwave receivers offered by Heathkit. My January 1970 Canadian Heathkit catalog has the GR-54 listed at $169.95, along with the less expensive GR-64 at $78.50 and the high-end GR-78 at $240.95, all in Canadian dollars. The GR-54 was the last vacuum tube shortwave receiver offered by Heathkit. Its successor was the solid-state SW717, introduced in 1971. The GR-54 is a tube-based shortwave receiver. It weighs in at about 19 pounds and covers the following frequencies in 5 bands. Band A, 180 kHz to 420 kHz long wave. Band B, 550 kHz to 1550 kHz, the AM broadcast band. Band C, 2 to 5 MHz short wave. Band D, 5 to 12.5 MHz short wave. And Band E, 12.5 to 30 MHz short wave. Heathkit built this as a deluxe shortwave listening receiver. Features include a speaker, crystal filter, product detector, S-meter, and dial light. The original kit even came with headphone plug and parts for a wire antenna. The manual explains how to build several antennas. A somewhat strange and unique feature is a Morse code key jack that can be used to practice Morse code. The design uses 6 vacuum tubes and 8 semiconductor diodes. It runs on AC power, can be wired for 120 or 240 volts AC, and takes about 45 watts of power. It uses a 1682 kHz IF frequency. Sensitivity is expected to be as good as 0.4 microvolts for single sideband or CW signals, and selectivity is 3 kHz. It can be aligned with or without test instruments. And like most Heath products, it was sold only as a kit. The front panel features a large illuminated slide rule dial. The dial is marked with various bands including amateur radio and shortwave broadcast, as well as the time and frequency standard station WWV. At the left is the uncalibrated band spread dial. If you're not familiar with the concept of band spread tuning, it's a secondary tuning control that allows accurate tuning of closely spaced frequencies of a radio band. On this radio, the band spread is uncalibrated and has set or 0 at the top and numbers up to 10 moving down. Typically, band spread is needed to tune single sideband or Morse code signals, and on the highest band where tuning is the most crowded. At the bottom of the dial is an S-meter indicating relative signal strength from 0 to 5. From left to right, the controls are band spread tuning, power and AF gain, RF gain, antenna trim, mode set to either AM or upper or lower sideband, band switch selecting one of 5 bands, and main tuning. The main tuning has a heavy flywheel and vernier, augmented by the band spread for finer control of tuning. On the right are switches for automatic volume control, automatic noise limiter, and receive or standby operating modes. The internal speaker is mounted behind ventilation holes in the left side. The rear panel is made from thick cardboard, presumably a cost-saving measure. There's a phono jack for the antenna connection, an S-meter zero adjustment control, and a connection for a CW key. I'll demonstrate this feature later. It has a standard 2-wire power cord and a 1/4-inch jack for headphones. Like some other Heathkit models, this can be used for headphones or an external speaker. If headphones are plugged in, they're connected in series with the speaker. With high impedance headphones, the speaker will be almost silent. With an external speaker, both the internal and external speakers will operate. The ferrite rod antenna on the back is used for the AM broadcast band only. Inside, you can see that most circuitry is on printed circuit boards, 2 large ones on the top of the chassis, and 3 more underneath, which are part of the band switch assembly. Some larger components, such as the power transformer, filter capacitor, tuning capacitors, and speaker, are mounted on the chassis and connected using point-to-point wiring. Additional wiring goes to the front panel controls. The use of printed circuit boards made assembly much less labor-intensive and error-prone, and overall a more pleasant experience than soldering all that point-to-point wiring. The labor in wiring was also reduced by the use of a pre-assembled wiring harness. The Heathkit catalog said typical construction time was 12 to 15 hours. Underneath can be seen more circuitry, including the band switch with associated printed circuit boards. Like many radios of this type, there's a noticeable thump on power-up when the unit is cold due to the current surge to charge the power supply filter caps. This is hard on the capacitors, power transformer, and power switch. I made a modification to put a CL90 surge limiter into the primary of the power transformer circuit. This is a special thermistor that has a high resistance when cold, but goes down to almost zero after a minute or so when it warms up. This reduces the surge on power-up and is recommended for equipment like this. The cost of the CL90 is about $2 to $3. There are different models of surge limiters available depending on the power requirements. It gets a little warm in operation, so you should keep it away from other components. I bought this radio from a local seller on Kijiji along with a TC2 tube checker. He said it belonged to his father, who was an electronics technician in the Canadian military. It came with an original manual dated 3/7/69, as well as a 1970 Canadian Heathkit catalog, which has the GR-54 model listed in it. When received, it was out of the case and some screws and other parts were in a plastic bag. It was complete except for missing the dial pointer for the band spread. It seemed to work when first powered up. The controls were a little noisy and the band spread dial cord had come unstrung. The plastic front panel on these units cracks easily. Almost all the units I've seen for sale on eBay have cracked panels to some degree. This unit is better than most and has only a little cracking of the front panel. I gave it a good cleaning inside and out. It had a strong tobacco smell and stains. Some of the white switches were yellow. The cardboard back was badly warped. I soaked it in water and then pressed it overnight under some heavy objects, after which it was almost straight. The piece of coax cable that connects 2 of the printed circuit boards was in bad shape, taped together with Scotch tape. I replaced it with a piece of new coax. The band spread dial pointer was missing. I was fortunate to find a dial pointer from another junk radio that fit almost perfectly. It just needed to be cut smaller and painted to match the main pointer. No other parts were replaced. Resistors were reasonably close to original values. I measured the ESR of the electrolytic filter capacitors and they looked good. I checked some key voltages against the manual and they were very close. I did a full alignment using the procedure for test instruments. I used an accurate DDS frequency generator and attenuator box. Alignment seemed to be reasonably close already. The tuning capacitor has no patterns, so you can only adjust the tuning at one band position, so the accuracy of the tuning dial is not particularly good. In fact, the alignment procedure for the top band suggests to adjust it at the high end and then split the difference when adjusting it at the low end of the dial. The procedure for adjusting the product detector for upper sideband and lower sideband is a little tedious and unusual. It relies on tuning to either side of the passband of the IF based on the S meter. I followed the procedure as per the manual and it worked quite well for me. The manual says that the alignment may need to be touched up when the bottom cover is installed. You can access the tuning coils through holes in the bottom. I didn't find any significant change with the cover on after I aligned it. The radio can be aligned without test instruments, a nice feature for someone who doesn't own test equipment. The procedure relies on tuning to stations on each band with known frequencies. This would be a little tedious and challenging. For example, some bands are only active at night and others during the day. You'd also need a decent antenna. They suggest for the long-wave band to call your local airport to get beacon frequency information. Fortunately, the front-end coils were adjusted at the factory and typically wouldn't need much adjustment to align the radio. Let's listen to the radio on the air. I have the radio connected to my amateur radio dipole antenna. Band B is the AM broadcast band. We can pick up a few local stations that are broadcasting here in Ottawa, Canada. Now let's try one of the shortwave bands. We should be able to pick up a number of stations this evening on some of the shortwave broadcast bands.
Squat puppetry and meet renowned artists who make them. ¿Zapatos?
This is some amateur radio teletype transmissions. The long-wave band is rarely used anymore. Formerly being used for commercial, aeronautical, and marine stations. Some of the long-wave bands are now being used by radio amateurs for low-speed, long-distance communication experiments. The CW or Morse code key feature was a little unique. It was meant for code practice. The receiver cannot transmit. To use it, you connect a Morse code key to the normally jumper terminals on the back. Then tune to a weak AM station and set the mode to upper or lower sideband. The resulting beat note can be used as a Morse code practice oscillator. The GR-54 was one of Heathkit's mid to upper range shortwave receivers. It would have been fine for shortwave listening and for casual amateur radio listening, but frustrating to use as an amateur radio operating receiver, as the selectivity, stability, and band spread are not up to tuning in crowded CW signals. But for the price, it was a good value and got many people started in ham radio or shortwave listening. The last two-based shortwave receiver offered by Heath, it was one of the few products that used printed circuit boards but not transistors. Like many Heathkits, there are various modifications published for the unit. I decided to keep mine original as I do not use it on a regular basis and keep it more for historical and nostalgia reasons. Thanks for watching. If you enjoyed this video, check out my other YouTube videos on vintage amateur radio and test equipment.